Today our topic is review of classical thermodynamics. In our topic we will study about what is the thermodynamics and thermodynamics variable. We also study about the laws of thermodynamics and also study about the processes in thermodynamics. Now we will move to our first question, that is what is the thermodynamics. That's the question, what is the thermodynamics. As we can see, thermodynamics is a combination of two words. First name is thermo and second one is dynamics. Thermo means heat and dynamics means motion. So in thermodynamics we study about the change in heat, and if we will define this, then this definition will be branch of physics that deals with the study of energy and its transformation in various forms. For example, we see these relation with heat, work, temperature and behavior of matter. In simple words, if we have a cup of tea and if we take it into the room, after a few minutes it will be cooled down. So where the energy will go, energy will go into the surrounding. That shows about the heat and its motion. When cup of tea was hot, its energy was very large. But with the passage of time, this energy transferred to the surrounding. So this is the motion of heat that's shown in thermodynamics. So before studying thermodynamics, we should know about the variables of thermodynamics. So what are the variables of thermodynamics? As we see that thermodynamics means motion of heat. And what is the variable? Variable are the quantities that describe the state or condition of a system at specific point in time is called thermodynamics variable. In simple word, we see that thermodynamic variables are temperature, pressure, and furthermore, as we see, temperature tells us in kinetic theory that particles in a system start to move very quickly with the passage of time. When temperature increase and further increase, then motion and the kinetic energy of these particles also increase. So this is the temperature, which is the variable of thermodynamics, and pressure is also variable of thermodynamics. In same sense, volume is also thermodynamic variable, which tells us about the space occupied by the system. There is an other variable of thermodynamics which name internal energy. This tells us about the motion of a particle, their position and their interaction. As we know that internal energy is sum of pressure, kinetic energy and potential energy and all other energies which causes to move a particle in a system. So these all are the things which are related to internal energy. There is another variable, that's the entropy, and we know entropy is the disorder and randomness of a system. In simple sense, if we have a system and large number of particles are in it, and with the increase of temperature their random motion will also increase, that shows the entropy of a system. So in same sense, enthalpy, Helmholtz free energy and Gibbs free energy are also variable that tells us about different thermodynamic variables. These thermodynamic variables in further lecture. Before this, we know about the basic laws of thermodynamics, in which first of all we will study about the first law of thermodynamics. So there are three laws of thermodynamics which are the very basic, and first law of thermodynamics will be the change in internal energy of a system equal the net heat transfer into the system minus the net work done by the system. If we see in mathematical step, delta U shows internal energy and change in internal energy. Q shows the heat and W shows the work. In simple sense, if we see that when we gave a heat to a system, delta U, which is internal energy, that will change and work will also done. For example, if we have a beaker and have a movable piston on it, When fire is on and temperature increase in a beaker, then piston will move upward slowly and slowly. With the passage of time, temperature increase, this piston will move. This means that work is done. So when we give heat to a system, internal energy increase and work will also done. In simple example, light bulb transfer electric energy into light energy and gave stoves transform chemical energy from natural gas into heat energy. So the second law of thermodynamics also tells us about heat is transferred from one body to another body only if the two bodies are at different temperature. In simple words, second law of thermodynamics tells us about the heat and change in heat. So for changing a heat, one level should be high and second should be low. So to describe second law of thermodynamics, mathematically we show an equation. Here ds is the change in entropy, delta Q shows the heat and T is the temperature. So entropy, temperature are the basic constituents of second law of thermodynamics. In simple example, if you have a iron rod and take heat and it takes heat from one side, gradually this heat will move to other side. This shows that on one side temperature is high and other side temperature is low. So change in temperature is given by second law of thermodynamics. In third law of thermodynamics, we study about the temperature of a system approaches absolute zero, the entropy of a perfectly ordered crystal becomes zero. The third law has important implication for the behavior of matter at extremely low temperature. So this is an important point which shows that third law of thermodynamics works on minimum temperature, low temperature. For example, at, at high temperature, water convert into vapors with high entropy. This means that when temperature increase, water molecules become vibrate and their kinetic energy will increase, which cause highly vibration, and due to this entropy is also increased because entropy is the disorderness of a system. So in water, when disorderness of molecule increase, temperature would also high. But at low temperature, entropy become less. This means that at low temperature, kinetic energy of gas molecules will be very low. This shows that with the increase in temperature, thermodynamic properties of third law of thermodynamics will be high, but at low temperature, entropy will be minimum, and also shows that minimum disorderness. So this was the third law of thermodynamics. Now we will study about the different processes in thermodynamics. So the thermodynamic process involves, first of all, isobaric process is one where the pressure of the system stay constant. For example, boiling of water to steam or the freezing of water to ice. This shows that temperature where the pressure of the system always remain constant, temperature changes. For example, boiling of water to steam. This shows that then what when temperature increase, water convert into steam, but when freeze, water convert into ice. In this case, the state changes but the pressure of a system remains constant. Second process is isochoric process. In this process, one where the volume of the system stays constant. So in isochoric process, we have condition that volume of a system always remain the same. For example, the molecule would move faster and the pressure would increase, but the size of container stays the same. This is a simple example that you have constant volume of a container. When temperature increase, vibration of molecules increase. This cause to increase in pressure, not increase in volume. So in this process, we have constant volume. For example, volume of the pressure cooker is constant. In pressure cooker, when food is boiled, we see that the volume doesn't increase, but the pressure increase with the increase in time because we gave continuous temperature heat which converts the internal energy increase, and this increase in internal energy causes increase of pressure, not volume. The third process is isothermal process. Iso means same, thermal means temperature. This shows that this process occur only when temperature of the system is same, and isothermal process is one where the temperature of the system stays constant. For example, when a liquid evaporates at a constant temperature, the process is isothermal because temperature is remain the same. For example, you gave 10 degree Celsius to a container, but you see that this 10 degree doesn't change. 10 degree remains the 10 degree when continuous temperature given to the container, but this temperature is same, not change. But one thing which we note that we gave temperature. This temperature causes to increase in internal energy and change the condition in a container. So our next process is adiabatic process. In this process, no heat enter, no heat leaves. This means that no heat enter, no heat leaves. Then how this process work? This process then work on compression and expansion. In simple example, you have a tire, burst of tire shows that the expansion, and in same case you have a compression process. This shows the adiabatic process. In half cycle we take compression, and second half cycle we take expansion. This is the complete cycle which shows the compression and expansion. In simple example, release of air from a tire is an example of adiabatic process. Now we'll see Maxwell relation to thermodynamics. As we know, Maxwell have large contribution in the field of physics. Maxwell relations are between various thermodynamic quantities like pressure, volume, entropy, and temperature. Maxwell relations are very useful to understand Helmholtz energy, internal energy, and Gibbs free energy. So all these relations will see in further lecture. So in today lecture, if you have a question, you can leave a comment below.